Algebraic effects are a concept from functional programming that allows to work with a shared, non-local state. You can achieve a lot of amazing things with them, like continuable error handling, promises and parallel execution, caching, timeouts, feature toggles, dependency injection, and many more. All that can be done in a unified, testable way, which could bring more cohesion to your projects. For me, coming from an object-oriented world, however, it was not something I could easily grasp just by looking at the definition. Fortunately, similar to monads, which I covered in episode 7, one doesn't need to fully understand algebraic effects or category theory to figure out why and when they might be useful. In this episode of Hanami Mastery, I will show you two simple but real-world examples of using effects to extend your Hanami or any other Ruby application. I will use Hanami Hello World application for showcasing these scenarios, but you can apply the concept into whatever you wish. For that, I will make use of Dry Effects, which is a neat little library that implements most useful algebraic effects in Ruby. Created by Nikita Shilnikov and Piotr Solnica and managed by the Dry team, it follows the simple rule of doing just one thing, but doing it in the best possible way. Let's tackle the first example. I have my Hello World application here and I would like to add a localization feature to support multiple languages. In my view, I have the message method exposed, which is rendered in the view. To add a very simple local check, I will update the exposure to accept the local argument, and based on its value, I'm going to render the localized string. For the sake of this example, I will hard-code the support of two languages, so for English I will render Welcome to Hanami Mastery, and for the Swahili, Karigo Hanami Mastery. In other case, I'm going to render the information about string not being localized properly. Then I need to pass the local from the action into my view, which will read the local from parameters. Voila! It works. However, how much overhead it is? Imagine you need to add localization in all your views. Updating all the actions just to pass the local doesn't seem to be the best approach. Also, for the need of testing my views, I need to be sure how exactly they should be initialized, and that's not something I would want to do. What I would love to do is to keep the amount of changes required to be made in my application to add the local support at the minimum level. It would be super convenient to just use the local helper whenever I need it without caring where and how the localization is resolved in my application. Therefore, to show the localized string, I will include the reader effect to my view, setting the reader to local, and based on this, I will show the correct translation in the browser. The custom rendering can be removed then from my action. The reader effect is the simplest effect available. It just reads the state and throws an error in case the state is used but not set just yet. In my case, this is exactly what will happen. Because I had not set my initial value to the local reader, trying to read it in the browser will raise an error saying that the state cannot be read. It's expected. And to solve it, I will write a little localization middleware that will be used by my whole application. In the config ru file, I will add the localization middleware to the stack, and then I will define it in a proper file. The simplest possible rack middleware just takes the application and calls it without changing anything. Mark Buske explains it very well in his talk about harnessing the power of function he presented at RubyConf in 2021. Check it out as it covers a few very interesting details about functional programming. Here, to properly set the locale, I will include the reader effect handler, setting the reader name to locale, and within a call method, I will wrap my app call by a with locale block. As a value, I will pass the initial local value resolved by the method I will write in a moment. Just for simplicity, I will extract the locale from request parameters and check if it's in the list of locales supported by my application. Then I will fallback it to the default language. Then I only need to define my constants. Having that, let's try it out. When I restart the server and open the browser now, you will see an English version of my welcome page, but as soon as I will add the local parameter, the translation will change to the chosen language. No changes in the behavior, but the implementation is completely different. This is awesome because now my app can access the local helper whenever needed, without taking care how to resolve its value. The responsibility of setting this up is extracted into a single place. Also super convenient in testing, but having that covered, let's go into another example. I would love my welcome message to show the current time in the browser too. I want you to think about how you would do it. The easiest way to do so is to just assign a time.now to a variable in the view and format it in the neat way. Is it your chosen approach? Don't lie, I know it is. It's fine, straightforward, and at the first glance, it works without problems. However, using timeNow in the class directly is a classic example of side effect. When I will want to test my view, I will immediately detect some problems as each test run will give me different results. For me, a code hard to test is a code badly written. To test my view, I would need to stop the timeNow, which means I would need to know exactly how my class fetches the current time and could not treat this class as a black box anymore. Whenever I would need to change it, my test would fail, even though the class behavior doesn't change at all. I'm going to deep dive into the best Hanami testing practices in Hanami Premium. Join now if you want to get to another level of Hanami expertise. But let's go back to the topic. To solve problem with tests, I could inject the current time from the outside as a dependency, or use an effect. Both approaches are fine, but you probably know how to pass the dependency into an object, and effects can be somewhat new for you. So here in my view, I will use current time. I can remove the timeNow call as I won't need it anymore. Then I will write the current time middleware to resolve the current time state. In the config.ru file, I'm going to add a new middleware to the stack and then define the actual class. The base for the withTime middleware is the same as in the previous example, so I will just paste the prepared code here. The only thing changed is that I need to include the current time event handler and then wrap my app call with the withCurrentTime block. Within this block, the current time variable can be used. And the amazing thing is that it's frozen, so it will return the same value during the whole request processing. From the behavior point of view, my app works exactly the same, but my view object now can be tested with convenience without stabbing timeNow or using solutions like timecop. My view doesn't care about setting the state anymore, so in tests, I can set it up in any way, and it will work exactly as I would expect. Algebraic effects is just a new tool to solve common programming problems in a unified, coherent way, ensuring our code is easy to test and easy to maintain. If you will write about other examples of using effects in Ruby, let me know. I will gladly include your articles in this post as references. And if you wish to contribute to Hanami Mastery content, feel free to do so as well. If you are interested to see other examples of using effects in Ruby, let me know. I am keen to come with other use cases for this topic in the upcoming episodes. It can become a while until effects will be widely adopted across Ruby applications, but you may be the one of the early adopters. For more advanced examples, join Hanami Mastery Pro or my GitHub sponsors to get an access to weekly premium episodes. I hope you have enjoyed this episode, and if you want to see more content in this fashion, subscribe to my YouTube channel and follow me on Twitter. I would like to especially thank to Andrzej Krzywda, Sebastian Hriber and Yuzeo, together with all my other GitHub sponsors for supporting this project and the whole Hanami Mastery initiative. Highly appreciated. You make this project possible. Thanks to all of you for being a part of this great Ruby community and for all the positive reactions you give. You are awesome. Feel free to check out my other episodes, and if you have any suggestions of amazing Ruby gems you would like me to cover or ideas how to improve, please mention them in the comments. Have a nice day and see you in the next Hanami Mastery episode.